A nice sequences question for number 3 here, and part A is asking us to find an expression for the nth term. Now we know all nth term expressions for an arithmetic sequence have an n term with a number in front of them and then a number at the end. So our objective is to try and find these two numbers. The first thing we need to look at is what's happening in the sequence, and in this sequence we can see that from term to term we're adding 6. The difference that's happening in the sequence is the number that goes in front of the n. So the first part of our nth term is going to be 6n. This says to us that this sequence is some kind of form of the 6 times table because it's going up in sixes. Now I know the original 6 times table. Once times 6 is 6, 2 times 6 is 12, and so on. But now I want this new version of the 6 times table. So the original version is 6. But I want 11, so the difference is add 5. Let's check that. I had 12, but I want 17, so again the difference is add 5. So my nth term is 6n plus 5. Part B, they're now asking us, if I carry on going with this sequence, would 121 appear in it? There's various ways of approaching this, and one of the ways could be we carry on writing the sequence to C. There's a much more simple and straightforward way, and that's to ask ourselves, would the rule 6n plus 5 at any point in the future equal 121? If it would, then we know 121 is in the sequence, and if it won't, then we know that it's not. So we're now going to solve this like a linear equation. So the first thing I'm going to do is I'm going to subtract 5 from each side, and that gives me 6n equals 116. And then I'm going to divide both sides by 6. So if we just do that as a separate calculation down here, 116 divided by 6. 6 into 1 won't go, so I carry the 1. 6 into 11 goes once, but I've got a remainder of 5. And then 6's into 56 go 9 times, but with a remainder of 2, so we could carry this number on. We don't need to do that because what we know is that the answer isn't going to be a whole number, therefore the answer is no, 121 won't be in the sequence. So what we'd say is no, 121 lies between the 19th and 20th positions of this sequence. It's not an actual position itself.